This video describes the properties and reactions of alcohols. Alcohols are organic compounds that contain an OH or hydroxyl group. Alcohols have high boiling points and low volatility. Short-chain alcohols are very soluble in water because they are polar and have hydrogen bonding. Because of this, they are frequently used as solvents. Methanol is the most simple alcohol. It contains one hydroxyl group and is toxic to humans. Ethanol is a commonly used alcohol which has two carbons in the parent chain. When naming alcohols, drop the E from the alcohol and add OL. Numbers should be added when necessary to specify the location of the hydroxyl group. If alcohols have multiple hydroxyl groups, they become diols or trials depending on the number of alcohol functional groups. There are different types of alcohols. The type depends on the bonding of the carbon that the hydroxyl group is attached to. If the carbon is bonded to only one other carbon, it is a primary alcohol. If the carbon is bonded to two carbons, it is a secondary alcohol. If the carbon is bonded to three other carbons, it is called a tertiary alcohol. Alcohols that contain more than one hydroxyl group are called polyalcohols. Notice how these two polyalcohols are named. The E returns to the alkane name when there are multiple hydroxyl groups. Hydroxyl groups can also bond to cyclic molecules. A benzene ring with an alcohol functional group is called phenol. Alcohols can be created by using addition reactions. As with typical addition reactions, an unsaturated hydrocarbon is the reactant. It is combined with water in the presence of a catalyst. The water splits into a hydrogen and a hydroxide. The H bonds to a carbon on one side of the double bond, and the OH bonds to the other side. Alcohols can also undergo elimination reactions. These reactions occur in the presence of a catalyst and are essentially a process that is backwards to the addition reaction that is used to create alcohols. Because water is removed from the hydrocarbon, the reaction is also called dehydration. The catalyst used is typically a strong acid. Organic halides can also undergo elimination reactions. A strong base must be present, and the product is an alkene. Notice that the byproducts are the halide ions and water. When organic halides undergo elimination reactions, we call the process dehydrohalogenation. When an alkane undergoes elimination reactions, we call it cracking or dehydrogenation. In the case of ethane, it can be converted to ethene. A catalyst is typically used, and hydrogen is a byproduct. Ethene is commonly made by putting ethanol through an elimination reaction. Different catalysts include sulfuric acid, aluminum oxide, and phosphoric acid. We are nearing the end of this unit. If you haven't already, begin making study notes or flashcards that will help you prepare for the unit exam.